right, so here we are for part 2 of being an event. I'm going to do as Joe did and just do a running commentary. So if you want to read along, of course, it'll be a little bit easier.
We also announce page numbers as well.
Yeah, I will announce page numbers as well. And feel free to for those at home, to interject at any point or ask questions or have a discussion. So part 2 is being excess, state of the situation, the one, multiple, the whole parts, or belonging or inclusion. So the basic thrust of this chapter is to sort of flesh out the sort of, not paradoxes, but the inconsistencies, the excesses that arise out of belonging and inclusion. And of course, relatedly, as we'll see with the axiom of the power set, between the situation and the state of the situation. And so, of course, this is, a return to all the previous philosophical discussions between the one and the whole, or rather between the parts and the whole, right, between all and totality. And so Badiou uses set theory to posit this radical excess that occurs between, again, the situation and the state of the situation, which will ultimately become its power set. So meditation 7, we have the point of excess, which is quite important because we get the theorem of excess in here. And so initially he's talking about belonging and inclusion, and again, he criticizes previous philosophy of trying to solve this problem of the parts and the whole, either through a one that unifies everything, or through an all that is a totality, which then subsumes everything, being Plato and Aristotle, respectively, in his perspective. Set theory distinguishes between the primitive relation, belonging, which is belonging, the element symbol, and the shorthand relation for inclusion. And so I think it's worth putting this up there. So what we have is we have the primitive relation, which is, marker works surprisingly well. We have primitive relation here, and then we have inclusion here. Now, it's important to note that inclusion is not a new relation. And he makes this point numerous times. So basically, what we have here is we have this formula. Sorry, my gamma's, actually all my Greek's awful, so just do your best with it. So this is what it means by inclusion, and I believe, if I'm not mistaken, this is for set A. Or, I'm sorry, I'm going to use the Greek alpha. So basically what we have is that for the supposition of all gammas, so that gamma exists, that for all gammas, if gamma is an element of B, or beta rather, then gamma is an element of A. So basically the way in which inclusion works is that gamma functions as the elements of a set of B, or rather, and so what we have is that insofar as B is a subset of A, or rather there's a set that exists, such that B is a subset of A, and that gamma is thus an element of A. So, actually there's a little diagram that I'll get to later. So this is somewhat esoteric, but basically what it does is, it means that belonging is sort of this second level relation. Again, it's formulated out of the primitive of belonging, but the elements that are included do not necessarily have the same properties as the elements that are that belong. So what he does.
This is illustrated in the middle of page 83, where he says, wherever I write beta is a subset of alpha, I could decide not to abbreviate and write, and then that formula you just wrote. So just pointing that out if the resolution doesn't turn so great out on the video. But that's in the first third of page 83.
Yeah, and you can find him talking about this from 81 to 82. And then you also have a slight variation here, which is, sorry, just one second. Sorry, in retrospect, I probably should have put all these equations up to begin with.
also maybe just switching to.
This is the equation that appears at the bottom of page 82.
Yeah, so what we have here is we also have the shorthand for the power set, and this is its rigorous form, or its more general formulation. So what we have, right, is for all A's, there exists a beta such that for all gammas, if a gamma is an element of B, if and only if gamma is an element of A. So basically, again, what we have is we have a subset. In this case, you can make a subset by determining the gammas such that, right, the gammas of A would be any sort of property of A. So for example, we could have the United Nations as our set, right? And what we could do is we could define a function of that set, which we'll call gamma, right? Which would be the countries, right? We could pick any number of sets for the United Nations. We could pick the number of building zone, the number of peacekeeping missions. But in this case, we'll have the number of countries, right? Which creates a subset, which is to say there is a set in the United Nations, which is a set of all countries, right? So these elements can be given as a power set. And so, of course, what happens then is we have the final formulation that we'll use much later and throughout pretty much the rest of the book, which is now, or alternatively, right, is that the countries would be one of the sets that would exist in the totality of sets of the United Nations. Sorry, it's a little bit of an esoteric example, I suppose. But then this is the easiest formulation that we will find of this. Actually, this is not there. But what we have is gamma is an element of the power set of A, if and only if gamma is, hold on a second, 82, 83, I think I might have transcribed it down wrong. 82, 83.
Gamma is the power set, or gamma belongs to the power set.
I believe it's the
If and only if Y is included in A.
This would be the one at the page of top
Top
of
of
83.
Yeah. Sorry, this is what happens when you do stuff late at night.
The markers in the bag are pretty terrible,
Okay.
but there's a red marker you grabbed and also add one.
Okay. Well, let's just go with this for a second. If and only if, oh, that was funny. Gamma. Okay. So actually, here's their new formulation, which makes a lot more sense to me. Sorry. What we have is that gamma is an element of the power set of A, if and only if gamma is included in A, right? So this is the formulation of the power set, which basically states what we're going to have in it. So in this case, it's not enough for A to be a part of or rather for gamma to be a part of A, or sorry, let me be very precise. It's not enough for gamma to be an element of A, right? Ban Ki-moon, right, is an element of the United Nations. I don't know why I went with the United Nations example, but we're going to run with it. He's an element of the United Nations, right? He is present in the situation that is at the United Nations. But that itself isn't enough. What he also needs to be is he needs to be included in the United Nations, which means being part of a submultiple. So what he needs to do is be included in the personnel of the United Nations. And we'll actually get to this more in depth with the state of the situation, but he doesn't exist in the power set as an element of himself, right? It's not the same element that belongs. The only time that he would be part of that power set is if he's represented, which is another way of saying a part that is included. Yes?
So the way I understood this was that you can't have a set of all sets, but you can have a set of all subsets.
Yes.
And what this does is eliminates Russell's paradox, because like gamma, for instance, can be included in a set of gamma, but it can't belong to a set of gamma.
Actually, no. This is what's wrong about that. is all of the axioms except for the axiom of the void are inferential.
Okay.
Which means you have something and you draw an inference for it. What you'll notice is that for the power set, what needs to be presupposed is that there are gammas.
Okay.
Right? So, and now, which again kind of holds up here, you can take a power set of any set, but what you can't do is it's not simply a generation. It has to actually come out of an existent set. Does that make sense?
Yeah.
Okay, so let's just move on a little bit. Page.